Kia ora tātou, ko Russell Death, toka anō, he kāmatia ko ora awa ahu. So I'm Russell Death, I'm a professor of freshwater ecology at Massey University in the North Island. However, 30 years ago I actually did my PhD in Canterbury, so those were back in the days when most of our water quality in New Zealand was actually quite good. More recently I've done some work in Banks Peninsula, but I've put up a picture here of your lovely river, and next to it a lovely river from where I'm from, and I think you can see that actually the issues that you're facing in your waterway are pretty much almost identical to the waterway issues that we're facing all around New Zealand. So although things are a little bit different in some respects, and I'll talk more about that in a minute, really the general scheme of what's going on with our waterways is pretty much happening all throughout New Zealand, sometimes in a better situation than yours, sometimes in a far worse one. The talk that I'm giving is from the perspective of ecological health. So I'm not talking about the economic benefits or costs, I'm not talking about the social aspects. And in fact, I'm focused much more on these little creepy crawly things. These are the animals that I like to work in. Most people don't know very much about them at all, but they're very good canaries of what's going on in a river system. I have done quite a lot of work with freshwater fish as well, but again, mainly talking about ecological health in the broader context. It's really hard to give these public talks. I've been giving quite a lot of these talks now, and it's quite depressing as a river ecologist to give these talks. I guess it's not helped by the fact that I'm called Dr. Death, and that really things are unfortunately just getting worse and worse every time I give one of these talks. We have the highest percentage of endangered freshwater fish in the world. We have some of the most polluted rivers in the Western world. We're giving away our water, even water from our national parks, and selling it overseas. We have virtually no monitoring of any of our endangered or threatened freshwater invertebrates, increasing levels of nitrate throughout all the waterways in New Zealand, and some of the highest levels of waterborne diseases in New Zealand. So I think Scott talked about a balanced and positive view, maybe after I'm finished. I think that if our waterways looked like this, I think far more people would be concerned about it. This is what people think about in terms of pollution. It looks terrible. You can see things floating in the water. You've even got rivers like in Hungary where it's red. There are rivers overseas which glow with radiation. There are some which are on fire. Unfortunately, the pollution in New Zealand looks like this. And to most of us, we think that's the natural scenario for our rivers. It doesn't look polluted. It doesn't look bad. It's not glowing. It's not on fire. If it was looking like this, I think far more people would be at this meeting. Far more people would be concerned about our waterways. Unfortunately, our pollution is kind of in disguise. It's nutrients, it's sediment. It makes our rivers green, it makes them brown. And most of us actually think that our waterways are meant to look brown and green when it rains and when it floods. They shouldn't look like that. The other problem with dealing with the health of an ecosystem is that it's quite a complex scenario. So when the National Policy Statement came out earlier in the year and Nick Smith was talking, all he talked about was E. coli. E. coli is just one aspect of health. When we think about our health, we don't go to the doctor and say, well, can you just take my temperature and see if I'm healthy? You want them to check your blood pressure, you want to check your bones, check your blood sugars, and so you can't just look at one aspect of a river or a lake and figure out whether it's healthy or not. You have to look at the whole thing. You have to look at how all those things are interacting together. So when we think about an ecosystem and its health, we need to think about all of these different variables, the nutrients, the habitat, the animals and the plants which are living in that. Any one of these that fails to meet that scenario is just like our health. If our blood pressure is too high, we get sick. If one of these things go wrong, the whole ecosystem goes sick and goes wrong, okay? However, most of the publicity really focuses on one or two things. So bacteria in our waterways is often in the media. I guess in part that's because of the human health associations. At the moment, the thing that gets all the bad press really are the nutrient levels in our waterways. And they are just one of many things which are going wrong with our waterways. This is just to give you some idea of the nitrate levels. So there are two main nutrients, and I'll talk more about that in a minute. There are the nitrates and there are the phosphates. Nitrates are the big problem throughout New Zealand. They're increasing. This is a model from NIWA showing the nitrate concentrations in every reach around New Zealand. The red are the high levels of nitrate. Blue are the good levels of nitrates. ANZAC guidelines, so where we would like healthy environments to be, are around here. And if I just highlight the red areas, so they are the Waikato, Taranaki, Manawatu, Canterbury and Southland. And I'll just leave you guys to figure out what's going on in those regions that might be affecting water quality. The other thing that I find a little bit frustrating is that there's always this talk about, are things getting worse, are things getting better? To me, it's not so much about whether things are improving or whether things are staying steady, or I guess it's bad if they're getting worse, but much of the water quality in in New Zealand now is so low that even if it improves dramatically, it's still going to be very, very poor. We are in a bad state. All of these red scenario rivers are in an extremely low state of ecological health. To me, the discussion we should be having is not whether things are getting worse or better, but that things are really bad and we should do something about it. Again, I think the public are getting far more behind this issue than they have in the past. That is, of course, encouraging politicians to get much more proactive about it. We've seen Labor get even more proactive about it lately. Only this year, there has already been 3 reports from 3 independent bodies to show that the state of water quality in New Zealand is bad and continuing to decline. So we had the government scientists, Sir Peter Gluckman, we had an overseas report, the OECD, and we had our own New Zealand statistics and Ministry for the Environment, all saying that things are bad and things are getting worse. Many of us in freshwater ecology and freshwater science have known this for years. I've been giving these same talks really almost for 30 years. The audiences are getting bigger and bigger, and the problems are getting bigger and bigger as well. But actually, I'm probably not saying anything different to what I was saying 10 years ago or 20 years ago. We've got lots of very good scientists in freshwater ecology and freshwater science in New Zealand. 20 plus years we've been recording that things are bad, that things are getting worse, and all we do is seem to continue to record that things are bad and things are getting worse. Again, in response to a lot of this science, a lot of this public concern with the fact that things are getting bad and things are getting worse, that we can't go down to our waterways and go swimming, the government has eventually decided, after a lot of pressure from the Land and Water Forum, to put up the National Policy Statement of Freshwater. So eventually this was released in 2014. This is the government's blueprint for protecting our waterways. It's just been under review, so they were meant to review it in 2016. They've just reviewed it again. And the only thing that they've changed is that they've made the standards for E. coli worse. The rest of it, from my perspective, is pretty much quite bad. It hasn't really improved at all. Rather than calling it clean water, I would prefer to call it just as dirty as it's always been water. This is a kind of a very general schematic of the ecosystem health of a waterway. So in the middle here, we've got our ecosystem health. Any ecologist, any freshwater ecologist in New Zealand that you would ask would highlight these things as being the important things. So you all know that we need to worry about our nutrients. We need to worry about how much water is in that river, whether it's flooding or not, the deposited fine sediments, the habitat, heavy metals. We need to know all about the animals and plants living in that. So these are the things that you would expect would be in a national policy statement to protect the ecosystem health of our waterways. This is what's in the National Policy Statement of Freshwater to protect river systems, okay? So we have nitrogen. That's kind of good, but actually only there as a poison, only as toxicity. It is not there to protect ecosystem health. There are numbers for lakes, but not for rivers. There is a measure of periphyton in there, and they have these other things as well, like ammonia and dissolved oxygen, but actually they're only important downstream of sewage discharges and only downstream of really bad sewage discharges. So just remind you, this is what we should be looking after. This is what the legal scenario of the National Policy Statement of Freshwater is attempting to protect our waterways by enforcing. Just to re-illustrate that, here's that map that I showed you before of all the nitrate levels around New Zealand. And remember, the red is bad, very high, blue is quite low. Under the National Policy Statement, it categorises these rivers into A, B, C or D. A is great, B and C are okay, D is the environmental bottom line. I think you can see that we go from the lots of red to lots of green, meaning lots of good. Maybe if you're living in Ashburton, you can maybe be a little bit worried, but really you're going from what I think is the reality of the data, lots of bad, lots of very high nitrate levels, to making it look like it's really good. There's lots of science already, as I said, in New Zealand. I really think that if we were concerned about our waterways, that we do have the scientific answers to address the issues. Of course, that doesn't stop scientists. There's continuing science going on throughout New Zealand. There's lots of money being spent on science, the National Science Challenge on land and water. I really think that they're just tinkering around the edges. To me, it feels like they're just rearranging the chairs, the deck chairs on the Titanic. Really, we have got such a big issue that, yes, a lot of these things are really good, but they're only really going to make a small change in the farming practices or the amount of nutrients that are leaching. Hopefully I'm wrong, but from what I can see is the situation is quite dire. We really need quite a dramatic solution. These science projects are good, but they're not going to provide that big solution that we're looking for. I don't actually think the solution is very complicated. I hate hearing politicians, whenever they're asked about the water management scenario, they always, oh, it's such a complicated situation, you know, how can we ever figure out what's going on and how to manage it? I don't really think it's complicated. It's basically these guys. We've increased these guys, doubled them essentially in the last 10 years. I'm sure many of you know that each one of those produces roughly the equivalent of 14 of us, and it's not treated. The biggest issue really is not so much the brown stuff, but the wet stuff coming out the back. It's very high in nitrate levels because we feed them food, which is far too high in nitrate. They don't process it, comes out the back, goes straight onto the grass, goes straight into the groundwater, and in most of New Zealand goes pretty much straight into our rivers and streams. The main drivers of lowering ecosystem health around New Zealand are essentially what I've been talking about already. So I've talked a lot about nitrogen and phosphorus, the nutrients. Too many nutrients means too much of this green slimy stuff. Also too much sediment, probably not such a big issue in your region, but certainly from where I'm from, this sediment gets into the waterways, plugs up where all these animals are living and affects their food. In turn, these changes affect the invertebrates which live there. You go from these like creepy crawly ones, which are the supposed good guys, to the slimy, squirmy ones, which are not good guys that the fish don't like to eat. The whole ecosystem changes, you lose all the fish, etc., etc. Okay, let's get back to your region and your river. This is a nice picture of your river. Really, as I said, the big issues in New Zealand are nutrients and sediment. And in fact, really, even in New Zealand, the big issue is not so much now both nutrients, but far more than nitrates. And clearly for your region, it's over-extraction. You don't have very much water in your river to dilute that water, and that is only going to get worse as climates change. So, too many nutrients, changing the whole ecosystem, and not enough water. Just to give you an idea of where you sit in the realm of too many nutrients, and I mean too many nitrates, this is a map of those same nitrate levels, but what I've done is I've colour-coded them based on some research that I've done around ecosystem health. So it's kind of the same thing as before in the national policy statement. Green is good, orange not so good, red is the bottom line, and so pink is even below the bottom line. And so you can see green in the obvious places, red in my region and some other areas, but your region is pink. The nitrate levels in your waterways are far higher than almost anywhere in New Zealand, and it's almost getting to the point where they're so high that it's hard to know what you can do about it. It's in a really bad situation. To focus in a little bit more detail, here we are in the foothills. Not too surprisingly, the nitrate levels are quite low. As those rivers move down onto the lowland, you increase the nitrate levels due to a variety of things, predominantly agriculture. You start going from those medium to low nitrate levels up to the moderate, which are the red, and the pink, which are the super high nitrate levels. So how can we solve this issue? Well, the kind of the dominant take-home message for farmers over the last 10 years, I guess, has really been to fence off your waterways. Fencing off your waterways is a good thing. It has stopped a lot of sediment and phosphorus getting into our waterways, and often a lot of the pathogens which are associated with that sediment. And that's why phosphorus is not such a big issue as it was maybe 10 years ago, because farmers have fenced off a lot of their streams. That stops a lot of the phosphorus getting in, but it doesn't help with the nitrate. The problem with the nitrate is it's very soluble. So when it's produced from the cow urine or fertiliser or whatever, it leaches down into the soil and into the groundwater very quickly and moves down into the stream. The phosphorus is bound to sediment, it stops getting into the waterways. Fencing is good, and farmers are always going on about the billions and billions of dollars they've spent on their fencing off their streams, but if it's like this, you might as well not even do it. There's no riparian strip. Yes, yay, the stream is fenced off, but it's not going to solve any of the problems. And furthermore, even the big riparian margins are not going to deal with that nitrate problem. So the science solutions, as I said, I think are pretty simple and straightforward. We don't really need more science to know that you have too much nitrogen in your waterways, you have too much nitrogen because you have too many cows with too much nitrate in the urine. You actually don't have enough water in many of your streams and rivers, and so yes, you could increase that by reducing abstraction, but I think you're up against it. Climate change is not going to be in your favour, and things are only going to get worse. The management solutions, well, to me, as a simple ecologist, the solution is quite simple. Less cows. A lot of people say, oh, that's less money, less exports. I think Alison's going to highlight that that doesn't necessarily have to be the case. You do have this added problem that a lot of the nutrients are in the groundwater and are going to take 20 to 30 years to get up to the surface. And so it might be that, even if you stopped any nitrate getting in, you're going to still see issues for a good time to come. Less abstraction, makes obvious sense, but the answer to less abstraction seems to be more irrigation. More irrigation can only occur with more intensification. More intensification can only mean more nitrogen. The only people that I ever hear saying that dams are the solution to save rivers are politicians and Irrigation New Zealand. I have never ever heard of a freshwater ecologist say, God, that river looks really sick, we better dam it and fix it. And actually around the world, many people are taking out the dams and trying to fix up things, not build dams to fix things. Conclusion, you've got too much nitrogen in your water, you probably haven't got enough water in your rivers. Interestingly, too much nitrogen is a far bigger problem than not enough water. If you're waiting for the government to solve your problems or look after your problems, I think you're wasting time. It's up to individuals. One would like to think regional councils to do something about it. I don't think the government, even if there is a change of government, is necessarily going to do what it takes to get things changed. If you want to have healthy rivers, you're going to need to reduce that nitrogen levels, and you're going to need to reduce it a long way. We don't need any more science. The critical issue is really about how you manage that in the social, cultural, economic context. And as far as I can see from what the plan is at the moment, it's not necessarily going to achieve that. Now, if this all goes wrong, up in the Pohongina Valley where I live, we're working on an alternative scenario. So if managing the nitrate by reducing agriculture doesn't work out, this guy here, one of my friends that I'm developing, has got an alternative strategy for dealing with the dairy industry. Thank you for your attention.